Hi guys, welcome back. In this video I will solve this problem. What will be the control word for an interfacing circuit as shown in figure. Also write the subroutine program to read the digital data from ADC. So in this question we are supposed to find out the control word and the subroutine program to read the digital data from ADC. So let's answer these questions. But before we begin, as always, I would like to tell you, if you haven't subscribed my channel yet, hit that subscribe button and that bell icon so that you can find videos related to education, programming and technology. Alright, with that being said, let's jump to the solution. Alright, now let's write the control word. Now since this is input output mode, D7 will always be 1, and we are using interrupt signal, so the mode of port A will be 1, therefore D6 and D5 will be 0 1. And again, if you are using SOC and EOC signal, then the mode of port A will be 0, and in that case D6 and D5 will be 0 0. So moving on, we have D4, and D4 is port A, and as you can see here that port A is input, therefore we will write 1 here. And then D3 is port C upper, and no information is given about port C upper, therefore we'll write don't care here. And then D2 is mode of port B, and since there is no information regarding port B, we can write don't care here also. And just a quick note, in most of the cases the mode of port A and port B will always be same. So if you are using a mode of port A as 1, then this will also be 1, and if it is 0, then this will also be 0. Now moving on, we have D1, and D1 is port B, so no information about port B, so don't care. And then D0, and D0 is port C lower, that is PC0, so PC0 is input, therefore we'll write 1 here. So if we consider don't care as 0, the control word of this interfacing circuit will be B1H. Okay, and if you still have any confusion about how to write control word, then you can watch my last video, because in that video I have explained how to write control word, and you can find that video on the top right corner of your screen, so go ahead and watch that. Alright guys, let's write the program. So what we're gonna do here is we'll write the whole program instead of just subroutine program, but in your answer paper you can just write the subroutine part, and I'm gonna indicate that subroutine part once I complete writing the program. But before we begin, we need to have port addresses, so let's quickly write the port addresses. This will be port A, now I have written up to A7 because as you can see here that CS select chip select is connected with A7, so I have written up to A7, but if it is connected with A15, then you need to write up to A15. Okay. So A7 generally indicates that it is IO mapped, and A15 will indicate that it is memory mapped. Okay, so now I think question the interfacing circuit is bit mistake, because if there needs to be a NOT gate here, okay, because if there is not a NOT gate, then A7 will be 0, and then whole port address will turn out to be 00H, which doesn't make much more sense, because in most of the question the port addresses are like 80H, and 81H, 82H, like that. So here needs to be a NOT gate, so that when A7 is high, the output of this NOT gate will be 0, and then 0 goes to here, and then 0 will become 1 here, so that this PPI will be selected. Therefore there needs to be a NOT gate, and if there is NOT gate, then A7 will be 1. Okay, so let me write 1 here, and in every case, in every writing port addresses, A0 and A1 will be 00, and no information is given for A2 to A6, so in that case this all will be don't care. So considering don't care as 0, the address of port A will be 80H. Okay, so as I said that there needs to be NOT gate, so keep that thing in mind. And then port B, the address of port B will be port A plus 1, so 81H, and then address of port C will be 81H plus 1, so 82H, and control register will be 82H plus 1, that is port C plus 1, so 83H. So these are the port addresses. Now we need to write the program. Alright, if in the question there is something like read the digital data from ADC and no information about processing and outputting the data, then we need to store that data into memory. So therefore program, let's say program here, and then for initializing the memory we will write LXI H memory. So this will initialize a pointer to an address held by this variable memory, so you can name it whatever you want. Now we need to output the control word from control register, so MPI A, and the control word is B1H out 83H. So this is for outputting the control word from control register. Now we need to check for interrupt, so IN, and the port address of C is 82H. And why port address of C? Because interrupt is connected with PC NOT, therefore port address of C. And then RRC for checking PC NOT, and then jump on 0 to you can say loop. Okay, so when PC NOT is 0, it will loop, because in that case the interrupt has not occurred. But if it is not 0, then interrupt has occurred. And one more thing, you can also write RAC, but in that case you will use jump on not carry. Okay, so now we have check for interrupt. Now we need to enable interrupt, and to enable interrupt there are generally two ways. So first one is outputting the control word for setting PC NOT So MBI A, and the control word for setting PC not is 01H, because see okay, let me this will be 0 for BSR mode, and this will be don't care as always, and we are setting PC not, therefore this will be 0 0 0, and for setting we write 1 here, so this will turn out 01H. Now MBI 01H, and then we need to output from control register, so out 83H. So this is the one way, and the other way is to just write EI. Instead of writing these two, you can just write EI for enabling the interrupt. Now we have checked for interrupt, we have enabled interrupt. Now we need to read the data from input ports. So IN ATH, because the input port is port A, so, and the address of port A is ATH. Now we need to store the data into memory, so move M comma A. So we are transferring the data from accumulator to the memory address pointed by this variable. Okay, so now we have read the data, we have stored the data. Now we need to just stop the program, so HLT. So this is the program, and the subroutine part is this subroutine part is this. Okay, so you can, in the exam you can just write this part. Okay, so now let me quickly revise what we have done here. So this is for initializing memory. Okay, and this is for outputting the control word from control register, so control word, and this is for checking interrupt, and this is for enabling interrupt. Okay, and this is for reading, and this is for storing the read input, and this is for stopping the program. So this is it, guys, and I hope you have learned something from this video. Thank you for watching.